Hi, everyone. I'm Robert Owens. I'm joined by Desirae, Baldivid, and Paul DiGiacomo. Together, we're Group 1. Let me walk you through our Lean Six Sigma DMAIC project. It's a problem every hotel is quietly losing points on, the front desk check-in. Our setting is a hypothetical 150-room mid-size hotel, but the benchmarks, drivers, and interventions all come straight from published industry research. We'll move through all 5 phases: define, measure, analyze, improve, and control. And by the end, you'll see how a sequenced rollout takes this process from failing to capable. Let's start with why. Here's the business case in 4 bullets. First, industry data pegs the average front desk check-in to 6 to 8 minutes, and our hypothetical hotel lands squarely in that range. Second, and this is the number that drives everything, Pingator's Cornell study found that U.S. guest satisfaction drops up to 47% once check-in crosses 5 minutes. And 5 minutes isn't a soft target, it's a cliff. Third, guest preferences have already shifted. Muse reports 70% of American travelers would prefer to completely skip the front desk. And fourth, the industry is responding. Kiosk adoption has jumped 72% year over year, according to Stay in Touch. The problem is real, threshold is well established, and the technology is maturing quickly.
With the scope, we try to be pretty disciplined. So looking at in scope, we're talking about the full front desk experience from walk up to key in hand, plus the self-service kiosk, staffing patterns, pre-registration adoption, and payment processing. Looking at the out of scope, such as the checkout, housekeeping, the reservation system itself, and the physical renovations, those are a project within its own. What we're looking at is the critical to quality metric that come right from the literature. We look at the cycle time at or below 5 minutes, the satisfaction at or above an 8.5 rating. I would recommend at least 85%. The primary why in cycle time in minutes, the data is simulated data set of 2,158 check-ins across 21 days. And within this data simulation, everything is fully reproducible.
Baseline fails every CTQ or cost to quality. So this just shows the baseline for the data, and it does not look very pretty. Again, it's not fully in a standard normal distribution. It looks like it is more skewed. So the histogram on the right shows our distribution of cycle times across all of the 2,158 records for the N, with the dashed line marking the 5-minute upper spec limit. And then notice how the bulk sits to the right of that line. And then the mean lands at the 6.74 minute mark, which is nearly 2 full minutes past the threshold. Over 82% of guests exceed the limit, and then the CPK comes in at a negative 0.34. And then the quick reminder for that, positive means the process fits within spec. 1.33 is the minimum acceptable value. So that means the 0 means the mean sits right at the spec limit. Negative means that the mean itself has crossed the limit. And then this process isn't just incapable. The average guest is already over the line before the conversation ends. So satisfaction 7.7, recommended rate 73, but overall it failed.
If baseline tells us we have a problem, the Pareto chart tells us where to dig. This is the average time for each of the 7 sub-processes that make up the check-in flow. Data entry leads at 101 seconds. Manual keystrokes to capture or verify guest information. Payment processing is a close second at 98 seconds. Together, Those two eat nearly half the total cycle time. Room assignment is a distant third at 56, and everything else sits in the 30 to 50-second range. Pareto principle in action. Roughly 2 out of 7 subprocesses account for about half the delay. Any intervention that attacks data entry or payment has true leverage. Key encoding isn't going to move the needle. So those rankings shape which scenarios we end up testing later.
Averages hide shape. The hourly pattern shown in the chart to the left is what closes the staffing conversation. Volume is flat in the morning, as you can see. Then a huge afternoon spike appears at the 3 to 6 p.m., which is nearly half the day's arrivals for check-in. But look at cycle time. It barely moves across hours. Queue wait time does not rise with volume, but the total cycle time per guest stays roughly constant. This tells us the check-in process under load isn't a different process. It's the same process, just run more times. Sure, staffing can soften the queue, but it doesn't fix cycle time. So that's a critical distinction worth noting when budget conversations come up later.
Delving deeper, we can look into the Pareto, which tells us where the time is spent. Looking further into the regression asks us why statistically. If we look and we can see the R-squared value of a 0.736, this explains only about 3/4 of the cycle time, which leads us to a strong load-bearing model. This is pretty striking, and we can look at pre-registered guests saving about 2.4 on average, with everything else being held constant. Prepaid guests save another minute and a half. Reservation complete saves a minute, and loyalty saves almost a minute. Looking into the staff count, though, we can see where the budget comes into conversation. The coefficient is a p-value of 0.31. This is not very significant. This tells us that adding a third person at a desk does not really reduce cycle time. This single finding leads us to a bottleneck within the design process and not the headcount. To make sure we are not wrong in our regression suspicions, we ran a direct hypothesis test. The box plot on the right visualizes the distributions. Every significant driver, whether it's pre-registration, reservation completeness, loyalty, or method of payment, shows clean separation. P-values below 1 in 1,000. The standout is pre-registration with a Cohen's d effect size of negative 2.31. For context, 0.8 is considered a large value. Negative 2.31 is huge. This means pre-registered and walk-up guests are essentially two different populations within the check-in groups. That's about as strong a signal as you'll ever get within a study.
The fishbone organizes candidate causes across 4 branches: information, process, technology, and people. What the regression showed us is the 2 branches actually drive cycle time. Information gaps at arrival and process steps built around those gaps. Technology and people matter, but they're enablers. They don't move the why by themselves. This is why the intervention set we're about to show targets information flow and process redesign first, not staffing or system overhauls. Root cause in 1 sentence. The front desk is recollecting information the hotel already has because we never asked for it before the guest arrived.
We tested 5 intervention scenarios, each a full resimulation, not an arithmetic projection. Scenario 1 pushes pre-reg adoption to 60% via mobile or web portal. Scenario 2 uses a small discount or loyalty points incentives to drive prepaid booking to 40%. Scenario 3 deploys an automated pre-arrival email for missing guest info, cutting data entry at the desk. And then scenario 4 combines all 3 of the process interventions. And finally, scenario 5 adds self-service kiosk with 30% guest adoption on top of S4 for scenario 4, the target state. One point to note on our methodology: each scenario reruns the entire 21-day simulation with the interventions dynamics baked in. So in S5, routing 30% of guests through kiosks actually changed queue dynamics for remaining desk guests. Here's the payoff. Both charts show the same progression, one in minutes, one in capability. So minutes is on the left, capability is on the right. On the left, cycle time drops across scenarios from 6.76 at baseline down to 4.01, or sorry, 10 at S5. Scenario 1 alone gets us to 5.42, real progress, but still above the threshold. S2 and S3 individually move the needle less because they target smaller Pareto drivers. S4, all 3 combined, gets us to 4.58, close but still over on tail cases. S5 breaks through to 4.10. Now the right-hand chart is the one that really matters. CPK across scenarios, baseline at negative 0.344. Every scenario improves it, and at S5, CPK crosses 0 for the first time and lands at plus 0.134. That sign flip is the inflection point of the entire project. The process mean has finally moved from above USL to below it. Kiosks are what close the gap. Knowing S5 is the target is half the answer. We also need a rollout sequence. The priority matrix plots each scenario on impact versus effort. The recommended order moves from cheap to expensive. First, S3, pre-arrival email. Effort 2, and automation against the existing property management system attacks the top Pareto driver, data entry. Second, S2, prepaid incentive. Effort 2, a pricing tweak, no tech build. Third, S1, pre-registration portal. Effort 3, because it needs a working mobile or web experience. Fourth, S4, the combined rollout once the 3 individual pieces are operating cleanly. And fifth, S5, kiosks. Effort 4, because the hardware is real capital, but the vendor typically manages the devices. Prove the process interventions first, build discipline, then earn the right to the hardware.
If we can keep our controls, we can keep our gains from eroding. So if we look here on the left, we can see the IMR, the individual and moving range, which is built on an S4 improved process. The center line at 4.1, upper control limit at 4.85, and lower at 3.35, with 0 days outside this control in this 21-day window. So the process, we can say, is statistically stable. Any future actions outside those limits will trigger an investigation so we can look into why. On the right is the monitoring cadence, and we can see those 3 nested rhythms from daily, weekly, and monthly. From the daily, we see a 10-second glance of shift handoff. Weekly, the indicators of the pre-registration adoption, satisfaction, reservation completeness. And monthly, we can look at the full dashboard of leadership. With 4 escalation triggers fully defined, we are closing out all of the DMAIC loop and preventions in lean manufacturing and lean failure, where we can focus on the improvements that erode the 6-month rollout.
All right, here's the scorecard. Baseline failed every single CTQ. Cycle time, 6.76 against the 5-minute target. 84% over the limit. CPK, deeply negative. Satisfaction, a full point below target. Only 73% would recommend. The recommended end state, S5, clears all 5 CTQs. Mean cycle time drops 39% to 4.10. Percent over USL falls from 84 to 35. CPK flips positive for the first time. Satisfaction reaches 8.8 and recommended rate hits 95. So the recommendation isn't build kiosks tomorrow. It's a staged rollout. Start with the 2 cheap process wins, then the pre-registration portal, then the capital investment in kiosk once the operational groundwork is all solid. A capable process from sequencing, not heroics. And finally, here's the sources we used. Highlights include studies and data from Cornell University, J.D. Power, AHLA, Muse, and the Hotel Tech Report. Again, I'm Robert Owens with Group 1. Thanks for joining us today for the presentation of our DMAIC project for reducing guest check-in time at a mid-size hotel front desk. Take care.